change, but not bad. Because you can use this pretty much every time and never use what I taught you earlier and still do okay on problems. So, whereas the stuff I taught you 2 days ago, it's like sometimes it's easier to use, but you have to be able to do what we're doing right now. So, if you can only do one, it's definitely better to be able to do this one. Okay, get those notes from yesterday back out. Let's see where we're at.
We should be on the back of the first page. We got the point slope form.
Okay. Alright, so there's something really important that I need to show you that we could have taught you in Math 1. I used to teach point slope form in Math 1. But what I found out is that my Math 1 students never really remembered the equation. And since they didn't remember the equation, they couldn't do it right. So I quit teaching it that way because the only linear equation they could ever remember was y equals mx plus b. So I just showed everybody how to do it using y equals mx plus b. So this is Math 1. This is not calculus right here. But we're going to use this every time we write the equation of a tangent line. Because on the AP exam, when you take your exam, it's going to ask you to write the equation of a tangent line pretty frequently. And when I taught it to you, I'm going to show you both ways that I showed you how to. So when I taught it to you, if I was the one that taught you to do this, then I told you to use y equals mx plus b. Right? And so we put the slope in as 4. And then this was our x and this was our y. So we put negative 2 equals 4 times 6 plus b. And so that's negative 2 equals 24 plus b. We subtract that subtract that 24, and we get negative 26 equals b. So the equation of the line is going to be y equals 4x minus 26. Okay, so if you had, I think Miss Ball also teaches it this way. So I think she also gave up on point slope form. Miss White used to teach point slope because she said you needed it in calculus, but we tried to tell her that it didn't matter because 90% of them were not going to make it to calculus, and we could just teach them this when they got to calculus. So that's our current policy. Is I'm just going to teach you this once you get to calculus instead of trying to. But really, it's easier to use point slope form because you guys are going to memorize point slope form and it's not going to be a big deal for me. I promise. Students do not have trouble with this once I've shown you how to do it. It's just my Math 1 kids that can't handle one more way to do something that can't. We got to stick with what we can do. The problem with this is it still works and you can still do it this way on the AP exam. The problem with it is that there were a lot of steps there, right? And so if I put my 2 and my 6 in the wrong place, or I lost a negative, or I said 4 times 6 equals 20, then I was going to miss that answer. So point slope form is, in point slope form, it is y equals m times x minus x1 plus y1. M right here, as always, is your slope. And then x1, y1 is a point on the graph. So the way that this works is I've got y, I'm going to write it down back here, x minus x1 plus y1. So my slope is 4, so I put 4 right there for my m. You do not replace the regular x or y, so this x just stays. And so my x1 is the coordinate of my point. So that point is 6, negative 2. So this is my x1, this is my y1. And so I do minus 6 plus negative 2. The reason I want you to do it this way for pretty much everything we do in calculus is on the AP exam, you do not have to simplify things. So on the AP exam, you can leave your answer like this. You did not do any adding, subtracting, multiplying, dividing, or anything where you might have made a mistake. You can just leave it. Yeah, so like if you distribute, you have 4x minus 24 minus 2, which is 4x minus 26. So it's the same, right? And if for some reason they ask you for the y-intercept or something, you could just simplify and get this. But if you are asked to find, we're going to be doing equations of tangent lines, which is going to be a little bit tougher than just the equation of a line. But at the end, you want to use this. I want you to use this form for it. Okay. So try the next one there, using y equals m times x minus x1 plus y1. So just plug it in. Right. Okay, so okay, you could simplify if it asked you to, but if it just says write the equation of the line, this is the equation of the line. And on the great thing about the AP exam is you don't, on free response, you don't have to simplify anything. For example, if your answer is, let's say the last step is you're supposed to do 2 plus 2. If you circle that and leave your answer as x equals 2 plus 2 and the correct answer is 4, you get credit for the answer. You don't have to simplify. Although leaving it as 2 plus 2 makes me want to scream.
Wait.
But
Could you technically also make it x squared? Why would you tell me
But Daniel has, now there is, you do need to simplify on some stuff because on multiple choice questions, you know, the answer choice, they're not going to have an answer choice that says 2 plus 2. But
So, does that mean, like, earlier, when we were doing, like, limits and stuff, the second something, like, when the H's cancel out, you can just leave everything?
it does, yes,
Like
it does.
that.
So, like, for example,
The second
on
the
this
H's
problem I
cancel
just
out,
did,
you can leave it at the first equal.
so I could leave it right here. You got to plug the 0 in. But you could leave your answer right here. Now, I want you, all right, now, Daniel, before you decide that you're never simplifying anything ever again, when you're doing homework, I do want you to simplify, and the reason is because these problems might show up on free response, but they also might show up on multiple choice. And if this is on multiple choice, right here's the answer that you're going to see on multiple choice. So I do want you to simplify. A good rule is like try to get your answer to match whatever's in the back of the book if it's an odd problem, because sometimes it is important that you simplify. But on the AP exam free response, if you leave the answer like this, it's fine. And in fact, I highly encourage you to leave your answer like this, because especially on this one, when you got to do negative 2/3 times 4, you might make a mistake. And if you make a mistake, then they're not going to give you the answer point for it. Whereas if you had just left it alone, you'd get the answer point.
So at some point, it would be better to stop writing than to keep writing.
Yeah. All right, so this is not calculus. This is math 1. You will not get a question this easy. But we will see problems that look like this. Okay?
What?
All right. Okay, this is the type of problem that you will see. All right, so there is no slope, but how could we find a slope? To find a slope, we find the derivative and then plug that in. We can't do y2 minus y1 here because we don't have like 2 points that we're dealing with. Yeah, I know. I told you it was math 1. You should have liked that better. So we need to find the derivative. We don't have an x and y coordinate. So to find the equation of a tangent line, we want to use that point slope form. So we need a point and a slope. So we do have the x coordinate. So I know my x coordinate's 3 at this point. So how did you get that the y is 1, Jack? Okay. So to find the point, we're just going to do f of 3 with the original equation, which is 3 minus 2, which is the square root of 1. And some of you on your test did not know what this is. What is the square root of 1? 1. Every year I have multiple calculus students that forget that the square root of 1 is 1. So you're not alone. They just leave it square root of 1 because they can't figure out how to simplify it. But on free response, it's okay because you don't have to simplify. If it had negative at the I. It is positive I, but only if it's like if you have square root of negative 1, that equals I. But square root of 1 equals 1. Okay. So, my point on my line is at 3, 1. I'm going to need that, but I got to find derivative first, right? So, if you're looking for the point on the graph, just use the original equation. So, when I'm looking for that point, I'm finding f of 3. Okay? That gives me my point on the graph. But for the slope, I need to find f prime of 3. I need to find the derivative and plug in 3. So you've got 2 options here. You can use that first rule that I gave you, f of x minus f of a over x minus a. Or you can use the other rule that I gave you, the x plus h minus f of x all over h. Either one will work here.
Didn't you say you were going to tell us a cheat today or something to get past all that?
No, not yet. Not yet. I do have another trick, but I'm not showing you that yet. It'll be a few days before I can show you that. So it's really up to you on which one you would prefer. One thing I would say, like on your free response questions that you've got that I have assigned to you, it would be better to use the x plus h over h one, because once you have the derivative, you might need to use that to answer another part of the question. So they might ask you another piece. So it's probably better. It really doesn't matter here. I'm going to use the one that we did yesterday, the limit as h approaches 0. But you don't have to.
So that was just like a safety, like if you're not sure.
Yeah, so like this one will work every time. The other one only works when you're doing it at a single point, which is okay because we're only at a single point here. So you could use either one. But x plus h minus 2 minus the square root of x minus 2 all over h. We okay plugging that in? Okay, how do we solve this? Multiply by the conjugate. It's ugly. So, but when we multiply here, the square roots are just going to go away. X plus h minus 2. We'll do the outside and the inside, but what's going to happen to the outside and insides? They cancel. And then we just have to multiply the last two, which is going to cancel the square root. But it's minus, put parentheses around this right here, because you still have to apply that minus to both terms there. And then don't multiply the bottom together, just keep it like it is.
This exact
I don't know if we did or not.
Yeah, we just did.
We did this one already. We did. I know we've done one similar. I don't know. It was a 1 instead of 2, but pretty much the same. All right, so if we subtract, I'm going to go ahead and distribute my negative, and I'm going to do that right here so I don't have to rewrite that. So you got an x and a negative x, a negative 2, and a positive 2. If everything without an x is not canceling, you did something wrong. So just for clarity, I'm going to write this next step. If you skip it, it's okay. I've got h over h times square root of x plus h minus 2 plus square root of x minus 2. So h's cancel. There's a 1 up here in the top left. And we're going to plug in a 0 for our h. So 1 over square root of x plus 0 minus 2 plus square root of x minus 2. This is 1 over square root of x minus 2 plus square root of x minus 2. Good luck. Oh, yes, let me give you that paper so that you don't. I will go over the response question, and I will record that and post it just so you can see it. But there's nothing required. Okay. So we can put these together. So this is our derivative. This is f prime of x.
So then, would you plug 3 into that? Slope at that point?
Okay. So this gives us slope at any points. Find it at 3. We're going to find f prime of 3, which is 1 over 2 times square root of 3 minus 2, which is 1 over 2 times square root of 1. And what is the square root of 1? 1, so this is just 1/2. So we did all of that work to find that this was our slope. And way back up there, we had our point was at 3, 1. So there's going to be a lot of calculus you've got to do, but now we're down to a Math 1 problem, right? We got to write the equation of the line that passes through 3, 1 and has a slope of 1/2. So I want you using that point slope form, y equals m times x minus x1 plus y1. So it's y equals 1/2 times x minus 3 plus 1. And leave it like that. Don't simplify it. Because you might make a mistake if you simplify it. So whenever it asks for the equation of a tangent line, you have to find a point on the line, which is usually pretty quick and simple. Just plug in a number in. Then you have to find the slope, which means the derivative at that point. And then you'll do your equation of the line. Okay? Questions? All right, let's look at a couple different types of questions here. All right, so this is still a tangent line problem. I think you'll like this one. Because the graph above shows f of x, and the table gives select values of the derivative of f of x, which is f prime of x. Write the equation of the line tangent to the graph of f at x equals -1. Then graph the tangent line on the graph above. Okay, so this one's quick. So we need two things to write the equation of a tangent line. We are looking at x equals -1, so we need a point, which is our f of -1. What is our f of -1? Alright, Thomas is right, it is -6. Because the graph, this is f of x. What does the table give you? This is the derivative. Yeah, you're correct. That's exactly what you need to do. So that means our point is -1, 6. This is the point where our line is supposed to pass through. Right? That's our point of tangency, we could call it. It's the place where we're going to draw our tangent line. Alright? So, I also need a slope, which would be f prime of -1, the derivative of -1. What is that? It is 4. I'm just reading that off of my table, because this right here tells me that this table is giving you the derivative. And so, I know my point is -1, 6. My slope is 4. So I'm just going to use y equals 4 times x plus 1 plus 6. Oh, no, I'm sorry. I wrote that wrong. It is -6 because that should be a negative right there. I didn't write my negative over here. -6. Okay, so this is your equation of your tangent line. It does ask you to graph it on the graph above. So if it passes through this point, it has a slope of 4, up 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1, go down 4 over 1. So it's going to be this line right here. And you can see that looks right. It looks like it's touching at that single point. So this is a calculus problem. But the actual work of it is easy as the Math 1 problem. But you have to understand where you get your point from and where you get your derivative or your slope from. That's calculus, yeah. But much quicker than doing the one before it. Say that just from the graph and table. I like these problems because there's not a lot of long work to do. A free day? Well, tomorrow's not a free day, but you have an AP classroom assignment, and then we're going to work on free response and test corrections. So it's not a strenuous day. We're not going to do anything new. It's not totally free, but it's freer than usual. Okay. All right, let's do this last one. I'm mostly doing this in case I give you some old problems. I don't think they put normal line questions on the AP exam anymore. But the normal line is the line perpendicular to a tangent line at the point of tangency. So, if I go back over here to this last one, this is my tangent line. The normal line would have looked something like this. That'd be a right angle. I didn't draw it perfectly. But it looks something like this. So there's just like one tiny step that's different. If they ask for a normal line, it's mostly going to be the same. Alright, so I got to write the equation of line. Normal to the graph of f of x equals 1 over x plus 2 at x equals 3. So I'm going to do this problem like it's a tangent line, and then there's going to be one little thing that's going to be different. So if I want to do a tangent line, I need a point and a slope. So to find the point, I just take, like in this particular case, I'm looking at 3. I just plug 3 in to the original equation. All right, so to find that point, I'm just doing f of 3, which is 1 over 3 plus 2, so I get 1/5. So if f of 3 equals 1/5, that tells me my point that I'm looking at, my point of tangency is 3/1/5.
On the test, like when you broke down like the non-points, would point be 1 point or be another point?
It depends on how the problem's weighted. Sometimes you got to have both to get the point, and sometimes there is a separate point for that. Yeah, it just depends on how many points that section's worth. Yeah, point is much easier than the slope, because for the slope we've got to find f prime of 3. All right. Just because on your free response questions, it's really going to be better to use the x plus h. I'm going to use that one again. H. Okay, so it's going to be 1 over x plus h plus 2 minus 1 over x plus 2 all over h. So this is a lot like the one we did for the not the warm-up, but for when we were going over the homework. What have I got to do? Common denominator. So my common denominators, I'm just going to take this first fraction does not have x plus 2, so I'm going to multiply by x plus 2 on top and bottom. And the second one needs the x plus h plus 2. Here. So that is going to give me x plus 2 minus, I'm going to keep this parentheses right here so I don't forget to distribute that negative. If you distribute it, that's fine. If I was working this problem by myself, I probably would, but I just want to be extra clear since you guys, to make sure everybody's following along with me. All right, here. Margaret, you're getting ready to leave, aren't you? Let's cancel some stuff before we split.
You can't cancel anything. Like flip it.
Yeah. So we got to distribute that negative. So we're going to have x plus 2 minus x minus h minus 2 all over this junk. Okay, so x's can cancel, 2's can cancel. We're left with that negative h there in the top. And so this is a h over 1, and dividing fractions is easy as pie. Flip the second and multiply. So I've got negative h over x plus 2, x plus h plus 2 times 1 over h. The h cancels. Since the h cancels, we can plug in. So you got negative 1 over x plus 2 times x plus 0 plus 2. Which is negative 1 over x plus 2, x plus 2, negative 1 over x, x plus 2 squared. It is almost. 21 was pretty much the same except for we had a negative 1 instead of a positive 2 there. So, this is our f prime of x. It takes us a long time to get there, but we've got our derivative. Oh, yes, sorry. I lost the negative there. And then, was it even 3 we were looking at? I've already forgotten. 3, yes. So we plug in the 3 to get f prime of 3. So negative 1 over 3 plus 2 squared is going to be negative 1 over 5 squared. So negative 1 over 25. This is our slope. Yeah. And so now that we have our slope, now that we have our slope, we also have our point, which our point was 3 1/5, and we just found our slope, which is negative 1 over 25. We're going to use y equals m times x minus x1 plus y1. So y is going to equal negative 1 over 25 times x minus 3 plus 1/5. And that, oh wait, hold on, that's not our answer. This, what is this that I've just written? This is my tangent line. Okay, it's okay, it's super easy. It's super duper easy.
Don't you just like slope the slope?
Perpendicular lines, flip the slope and change its sign. So y equals positive 25 times x minus 3 plus 1/5. This is your normal line. Since it asks for a normal line is the line perpendicular to the tangent line. Yeah. Right. If it, in most questions you're going to get are going to ask for that tangent line. You're not going to see normal line much. I'm just throwing it in here because there are some old AP questions that I like to give sometimes that ask for normal line instead of tangent line. And it's just one little flip. So.
Normal line is just the line that's perpendicular.
Yes. At that same point where it, yeah. Mm-hmm.
So this slope goes from negative 1 over 25 to just positive?
Yeah, because you're flipping it, which is making it 25 over 1 and changing its sign. Yeah. Okay, questions? All right, so it's the same process every time. Point, just plug in the number. Slope is where it's difficult because you've got to find that derivative first, and that's what takes so long, and then you almost forget what else it was you were trying to do. But once you get that derivative, you just have to plug in the number and use your point slope form for your line. Okay, questions? Okay, let's look at the second part of what we're going to do. This should be quicker.
We're halfway there.
Oh no! I think there were 2 pages. No. Oh no. Okay. Okay. Yeah. Okay. Oh, y'all are not ready for this.
We're not worthy.
If you want to learn the shortcut, you're going to have to go to check out Khan Academy or something. I'm not teaching it to you yet. Because if I teach you now, you will never do the limit definition.
Yeah, you're right. That's the point.
I mean, in real life, probably not, but on the AP exam, yes.
In real life.
questions, you'll be able to use the shortcut on AP things. They occasionally give you questions where you shortcut, so that's why I got.
It's like the rule, how.
Yeah.
I thought I saw a pattern in the notes yesterday. But
Yeah, if you're starting to pick up on patterns,
Yeah, I did.
It makes so much sense though.
Yeah.
It makes so much sense. Which blows my mind. I saw the pattern, but I couldn't
I did
figure
not
out
see
the
that.
well, yeah. Right now, I still expect you to be working this out the long way, but I promise I am going to tell you the shortcuts before long so that we don't have to do limit definition of derivative forever, because it will take a long time. All right, so we're going to shift gears here and look at estimating derivatives. I think you will like estimating. It's pretty straightforward. Okay, so
I probably already do.
let's see.
The statistical probability, that's what she's saying.
Let's see. What have we done here? There we go. Okay. All right, so just really quick, I'm going to graph these points.
Yeah, what? Like 2 tabs.
Oh, because I didn't mean to. There we go. Because sometimes whenever you're watching somebody else use a computer, you just want to like take the mouse from them and tell them that they are way too slow. Like if I ever watch my husband do something on the computer, I just want to like tell him right here. And it's not that he's slow at using it. It's just like I'm sure that you guys probably feel that way sometimes whenever you're watching watching this. So I've got a weird set of points here.
Why is it like that? Why is it? It's like such a good line.
I think it's probably just because I just made up a bunch of points whenever I made up this question. So let me, I probably just made. Oh, let's not do that. Let's get this where we can. It's not. Okay, there we go. That's better.
The thickness.
Okay, so they have only given us points, so we don't know exactly what happens with this graph. We do know that this stupid point right here is making things crazy, right? But the graph might look something like it could do crazy stuff. We don't even know what it does, right? But we are asked to estimate f prime of 4. So if I look at this graph, if it was this green line that I have right here, 4 falls about right there. So I don't really know what I might should hold on, let me make it even look curved. So like let's say
Wait, did you just throw that jump on the floor?
yeah, I'm just making up something here. Right, I don't know that green graph looks like it does. But if 4 is right here, so if I go up here to my graph, here's that point. All right. So I don't know the tangent line at that point exactly.
But it could be infinity.
But the closest guess I could make would be just finding the slope between the points that are the two closest points. Right. So if I'm estimating the derivative and all I have is a table, then we've really already done this before in this class when we were looking at estimating speeds on some of that very first stuff that I gave you. We were trying to estimate how fast something was going, so we just use those points closest to it. So we would just use the point 2, 11, and 5, 7, and find the slope between those points. So we'd have 7 minus 11 over 5 minus 2. So negative 4 over 3. So f prime of 4. Now this is really important here. Does our derivative equal negative 4/3? It does not, because we are estimating here. So the symbol you need to use right here is the squiggly equal sign, which means f prime of 4 is approximately negative 4 over 3.
And that could be completely wrong.
Right, it might be, right, if we actually knew what this was, it might be completely wrong. In fact, it looks like it's like a piecewise function or something with just a dot somewhere, but this is our estimate, and it's the best estimate we can make given the information we've got. Okay, does that make sense? So, yes.
Sorry, I couldn't hear what you said.
Yeah, it could be. Yeah, like the most simple thing, it would just have a hole right there and be linear the rest of the way, which would at least make me feel a little better about that graph. But I'm sure I didn't even graph that whenever I made up this problem. I just like made up numbers. That's why it looks like it does. All right, so use the graph of g of x to the left to estimate f prime of 0, f prime of 6, and f prime of 4. Yes.
So how do you know which point is the closest?
Since you're doing f prime of 4, 4 would fall between 2 and 5. So that's your x value. That 4 is your x value.
Okay, I thought it was
Yeah.
the same one. 'Cause I was like 0 to 2, 10, 11, those are like,
Right, not the ones that are closest to each other, but the closest to whatever point you're estimating. So like they had us find f prime of 6, we would have used 5 and 8.
okay.
Yeah.
So yeah, I don't know.
Okay. So f prime of 0, that's right here. All right, now we are really estimating here.
It looks to me like it's about negative 0.1.
Okay, so
That's what I was putting.
it is a negative slope. It is definitely less than 1. Because, so, you know, what I've drawn here would have a slope of negative 0.2. But if the main thing is you've got an estimate that's negative, it must be negative, and it should be somewhere between negative 1 and 0. It should not be like negative 2.
Would you prefer fractions or decimals for working?
Doesn't matter to me, either one.
So how would you accept an answer? Would you just have to be a range answer?
Yeah.
Okay. So you'd say anything.
And most of these are going to show up as multiple choice, and it's going to be more like a process of elimination sort of thing. Like, it might be more like which one has the lowest, like which one's slope is the least. So which one has, you know, not the flattest line, steepest negative line, if that was the question. Yeah. So f prime of 6 is over here. Right here is 6. So what do you guys think for that one?
Negative.
Actually, I might should have drawn. I think that's pretty negative 1-ish right there, don't you think?
Negative. Negative 1.
I'd go with negative 1.
So we're just guessing?
We're just guessing.
Oh, okay.
So again here, it must be negative. You can see it is a little steeper than whatever you had for your red line, my red line here, so make it bigger than that. Like if you guessed negative 3/4, that'd be okay. If you guessed negative, you know, negative 1.5, that'd be fine. Negative 3/2, something like that. So it's just a guess for these. F prime of 4. Oh, yeah, does not exist. Good. because you have a vertical asymptote there. So yeah, does not exist. Or I guess we might should we say undefined there? Oh, Thomas, thank you so much for correcting my error here. Squiggly lines, because
I just thought those were really bad squiggly lines.
it's got to be on. It can't be just things done right now, because I mess that stuff up too often.
Just let her done that, then she would record it. She's recording, and then she.
It can't be on classroom recordings. It's got to be on something like a worksheet or a quiz or a test or something like that.
Call that for just one.
So the last one would not be squiggly lines because we know for sure that it doesn't.
Right.
I'll print it out beside it. I'll turn it
And then you'd be like,
Does not
say,
All right, true or false? For all x's in the domain of f, f prime of x is less than or equal to 0.
False. I have no idea. False.
100% false.
Okay.
Can that be spoken in terms of normal English? Probably not.
Okay, so let's talk about domain first.
Oh wait.
Domain means wherever it's defined. This you do have one place where this is not defined. It's at 4, but it's telling us to ignore 4. We're only talking about where we have a domain here. So ignore 4 because 4 is not in the domain. So what is f prime of x? It is the derivative. Which is the slope of the tangent
Jack, you're freaking wrong.
at any point. He was right.
But the lines, so the line's like going down and everything.
Okay, what does this mean right here when we say less than or equal to 0? It's negative or 0. Okay, so everywhere you draw a tangent line, even if it's over here, it's still decreasing right here. It's decreasing right here. Like every tangent line you could draw anywhere has a negative slope. So this one is true. True. True.
They'll take it down.
If they had not put that for all x's in the domain of f and just said for all real numbers, f prime of x is less than or equal to 0, it would be false because it doesn't have anything at 4. But since they said just for the domain, you don't have to worry about any places where it's undefined. All right. Okay. Yeah. It was easier then, wasn't it? Okay. So, what are we finding when we see f of negative 1 minus f of negative 3 over 2?
I just drew a straight line. It's great.
Is it perfect?
Yeah.
It's a miracle.
I don't know.
All right. So, right here, f of negative 1 minus f of 3 over 2. It's a slope. Between what 2 points? X equals negative 1 and x equals negative 3. Because, and that bottom is 2 because negative 1 minus negative 3 would be 2, right? So they went ahead and simplified the denominator. Sometimes they do that, sometimes they don't.
Wait a second. So is f of negative 1 is not a derivative?
No.
It's just a
No, because if it's a derivative, you'll have that little tick mark behind it.
Okay, so it's simply the point.
Yeah, so we're just finding the slope between the points at negative 1 and negative 3. So those are marked here for us, negative 1 and negative 3. Those points are marked. So we're talking about the slope of this line, which I couldn't actually find since I have those there, but I'm not even going to do that.
So does that mean it has a
Yes, so we're thinking about the slope of this blue line right here. What is the other side of this inequality? Negative 3 and 5. So I'm thinking about 5 is over here. So I'm thinking about the slope between negative 3 and 5. So which one is steeper, which means it'll have a higher slope, the blue or the red? Okay, so we would put greater than for that. Okay, B looks different than the first part of A, but it's still slope formula between negative 3 and 1. It's just written a little bit different. They put the negative 3 first. They didn't simplify the denominator. So it's still the slope of that blue line. It's still going to be positive. Yeah, it's also a negative on the bottom.
Nobody understands what you're saying.
It's going a little fast there. In the denominator there, Thomas, you'll have negative 3 plus 1, which will give you negative 2. So you get negative 6 in the top, but you also get negative 2 in the bottom, which still gives you a positive. He just needed a little slower, maybe.
I just need words.
Okay, so what is f prime of 3? The slope of the tangent at x equals 3. So at x equals 3, or I'm sorry, negative 3. Negative 3. So at negative 3 right here, my tangent line, if I could draw it in, it's hard to know exactly what it is, but is it steeper or less steep? It is steeper. So the alligator needs to eat the f prime of negative 3. Yeah, if you want to put some teeth on the alligator. Yeah, we're doing inequalities right now. Yeah. So, see, this is still our blue, slope of our blue line, right? Now we want f prime of negative 1, which is slope of the tangent at negative 1. So I'm going to use purple here. So that would be a tangent line that looks something like this. I'd say probably about 2. Is it? So the alligator needs to eat the left side. So it is greater than the slope there. Yeah, I kind of like them too. Let's not do 5.
We're supposed to skip over.
I'm going to skip it. Alright, so. Alright, we got, this is f. This is the function f right here. We've got to sketch f prime. So f prime of x is the slope of f at whatever point that you're looking at, right? So if I look right here, let's say at negative 6, that's negative 6 right there. What's the slope of that line? Oh, I didn't pick one very easy to do, did I? I think it's negative 5 halves. Does that seem right? It hits in between lines. It's annoying. Why did I do that? Or maybe it's negative 2.
That would be 2.
I think it's negative 2. We're going with negative 2. So f prime of negative 6 is negative 2. Slope is negative 2. I'm going to plot that over here because this is my f prime of x graph. So negative 6, negative 2. Okay? What about if I did f prime of negative 2? What's the slope there? It's the same. It's still negative 2. What about f prime of 0? Also negative 2. Where does it quit being negative 2? At 1. Actually, it's 2 because this is counting by 2's here. So at 2. Now, right there at this point, what's the slope of the line at that point?
It doesn't have a slope.
It depends on which side you want to look at, right? From the left side, it looks like it's negative 2, but from the right side, it's positive 2. So if it's not, if you have a sharp turn in the graph right there, we can't say that there is a derivative there. So what I'm going to do, the slope is negative 2 everywhere up until that point. I'm going to put an open circle because right there at 2, I can't tell what the slope is because I got two different slopes coming together. What is the slope, like if I'm doing f prime of 4, now the slope is positive 2, right? And f prime of 8 would also be positive 2. So right here, we're going to skip up here to positive 2, and we'll have them.
I thought you could have two open circles.
You can. You don't most of the time on piecewise functions, but on this one you have to because you don't have a derivative at that point. We'll talk a little more about differentiability. Yeah.
I can actually, I realized what it needed to be before, and I couldn't think about it.
Yeah. All right.
Is that it?
Yeah, we're gonna stop now. Monday. So this is not what you have on Canvas. Canvas. Let's look at it really quickly. All right, but I need to take a few of them off on Canvas. And I'll take them all off. But I am going to do a couple things that maybe will make your life a little bit easier. Okay, this one right here. 25, 29, 30, 32. Okay. All right, I'm going to take out 30. And don't do 37 through 40 yet. I really don't like, I tell you what, let's just do these. These are not, these four right here are tangent line problems. They are not the estimating stuff. Mostly because I needed to finish one more thing before I gave the textbook estimating stuff and I didn't. So 25, 29, 32, and 34, these are tangent line problems. Yes, this is on Canvas.
25, 29, 32.
Yes. Oh, and I'm going to make this due on Monday. Because tomorrow we're going to work on some free response questions, and I'm not going to check this until Monday.
The free response questions and stuff, when is that due?
That's due Monday.
Oh, it's also
Due Monday.
Okay.
Yes, also due Monday.
So the paper that you gave us that we do weekly is due Monday, or will we have a quiz Monday?
Yes, we'll have a quiz Monday.
Okay, so we'll have a quiz Monday, plus that paper, plus the AP classroom, plus the textbook.
Yes. Yes. So you got those four from the textbook, AP classroom, and
Free response.
free response. Yeah, those are, since you will not be here tomorrow.